Imagine, for a moment, the same time period, the present age of technological marvels and interstellar ambition. Picture yourself standing on the edge of an alien world, a place where no human has ever set foot, and yet we have seen it in stunning clarity. Mars, the red planet, once cloaked in mystery and hidden behind the veil of immense distance, is now being unraveled piece by piece through the determined efforts of humankind. NASA's relentless pursuit of knowledge has steadily brought us closer to understanding this barren yet endlessly fascinating world. At the very heart of this incredible mission are the rovers, silent explorers that tirelessly roam the Martian landscape, capturing history in motion and transmitting it back to Earth with awe-inspiring precision. These robotic explorers are far more than mere machines. They are powerful symbols of human curiosity and determination. Each one is a triumph of engineering, built to withstand the harshest conditions imaginable and to push the boundaries of our knowledge about the cosmos. These marvels of innovation navigate treacherous terrain, battle punishing temperature extremes, and survive fierce dust storms, all in pursuit of knowledge that may one day alter the course of human history itself. Each mission builds on the legacy and success of its predecessors, continually refining technology, expanding our reach, and bringing us ever closer to our ultimate goal: understanding Mars well enough to one day send humans to explore it in person. Decades of space exploration have led us to this moment. The story began humbly, with small, clunky landers that managed to provide the first grainy images of the Martian surface. These humble beginnings paved the way for the next wave of explorers, the rovers, each generation more advanced than the one before. Spirit and Opportunity marked a historic milestone, confirming the presence of ancient water on Mars. Curiosity followed, dramatically transforming our understanding of Mars's past climate, revealing clues that the planet once had the conditions necessary to support microbial life. And now, we have Perseverance, the most sophisticated robotic scientist ever sent beyond Earth's boundaries. This latest marvel carries with it the weight of human ambition, armed with technology specifically designed to search for life itself. But these rovers were not created overnight. They are the culmination of decades of meticulous engineering, intensive scientific research, and countless trials and simulations. The development process is rigorous, involving testing after testing to ensure that these machines can endure the brutal conditions on Mars. They must be able to withstand radiation, survive extreme cold, and navigate a rocky, unstable terrain with ease. And then comes the landing, a nerve-wracking, high-stakes spectacle that demands unparalleled precision and technological innovation. From the airbag-assisted landings of early missions to the awe-inspiring sky crane system that gently lowered Perseverance onto the Martian surface, every moment is fraught with tension. A single miscalculation could lead to the loss of years of work and billions of dollars. But when everything works as planned, the results are nothing short of transformative. These rovers open doors to discoveries that continually redefine our understanding of Mars and edge us closer to resolving the age-old question: are we alone in the universe? Perseverance landed in Jezero Crater, a site carefully chosen by NASA scientists. This location was once home to an ancient river delta, making it one of the most promising places to search for signs of past life on Mars. If life ever did exist on the red planet, Jezero Crater is where it might have left behind its traces. The rover's high-resolution cameras have captured breathtaking images that show layered rock formations, visible signs of past water flow, and chemical compositions that could indicate the possibility of biological activity. Each photo that Perseverance sends back to Earth is not just a window into another world, it's a potential clue in one of the greatest scientific mysteries of all time. Did life ever exist on Mars? The importance of Jezero Crater cannot be overstated. Its geological features indicate that it once held a lake, making it a prime location for the study of ancient microbial life. Scientists believe that if Mars ever supported life, then signs of it might be preserved within the clay minerals found inside the crater's ancient sediment layers. Perseverance is equipped with cutting-edge scientific instruments, including Sherlock and Pixel, both of which are designed to analyze rock samples at the microscopic level. These instruments are crucial in the search for biosignatures, telltale signs of past life. The mission is meticulous and methodical, moving slowly and deliberately across the Martian landscape. The rover drills into the surface, collects samples, and stores them in sealed containers, with the goal of eventually returning them to Earth for further study. These efforts bring us closer than ever before to answering the profound, age-old question: are we alone in the universe? Yet Perseverance is far more than just a camera on wheels or a rock collector. It also carries a groundbreaking experiment that could change the trajectory of human history: MOXIE. The Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, is designed to produce oxygen from the carbon dioxide-rich atmosphere of Mars. This is not just a scientific curiosity, it's a critical blueprint for the future. It represents a vital step toward the day when astronauts will walk on the Martian surface, breathing air made from the planet itself. MOX's success could lay the groundwork for future missions that require self-sustaining life support systems, reducing our dependency on Earth for oxygen and enabling long-duration human exploration of the Red Planet. This technological advancement is crucial for long-term space travel and planetary colonization. Transporting oxygen from Earth is both costly and impractical, especially for extended missions. In addition to creating breathable air, MOX's underlying technology could one day be adapted for fuel production. This would enable the generation of rocket propellant directly from Mars's natural resources, a leap forward that would significantly impact mission planning. It would make return trips from Mars more feasible and would open the door to sustainable, long-term exploration. The dream of establishing a human presence on Mars is slowly becoming a reality, driven by innovations like MOXie that make the impossible seem within reach. No one was certain whether powered flight was even possible on Mars. The planet's thin atmosphere and extreme environmental conditions presented enormous challenges. But on April 19, 2021, Ingenuity, the tiny, experimental helicopter, defied all expectations. It lifted off, hovered for a few seconds, and landed safely, achieving the first powered flight on another planet. What began as a simple technology demonstration has since evolved into something much larger and more significant. Ingenuity has completed dozens of successful flights, acting as a scout for Perseverance by mapping terrain, identifying hazards, and proving that aerial exploration of other planets is not only possible but essential. This tiny rotorcraft, weighing just 4 pounds, carries enormous significance. Ingenuity operates autonomously, making real-time decisions in an environment where communication delays make direct human control impossible. It has exceeded all initial expectations, adapting to unforeseen challenges and extending its mission far beyond the original 30-day test period. Its ability to provide aerial reconnaissance is invaluable, helping Perseverance avoid dangerous terrain and zero in on the most promising scientific targets. Ingenuity's performance has demonstrated that future missions could incorporate flying drones to explore regions that are inaccessible to ground-based rovers. This breakthrough has the potential to revolutionize planetary exploration, offering new perspectives and capabilities that were once considered unimaginable. Beyond its scientific mission, Perseverance also carries a legacy of human culture. Hidden in its design are symbols, messages, and even the names of millions of people who signed up to have their identities carried to another world. The phrase "Dare Mighty Things" is woven into its parachute, a silent yet powerful reminder of what humanity can achieve when we reach beyond the limits of the possible. The rover also honors frontline workers who battled the COVID-19 pandemic, a touching tribute from one world to those who fought for another. These seemingly small details represent something much larger: humanity's collective spirit, creativity, and drive to explore the unknown. Space exploration is not just about science, it's about inspiration. It's about reminding us all that even in the face of adversity and uncertainty, progress is possible. Perseverance carries 3 microchips inscribed with the names of 10.9 million people who participated in NASA's Send Your Name to Mars campaign, making them symbolic passengers on this extraordinary journey. These cultural and symbolic gestures highlight the unity of human ambition, connecting people across the globe in a shared dream of discovery and exploration. The mission is not just about Mars, it's about the future of space exploration itself. Perseverance is collecting samples, tiny bits of Martian rock and soil, that for now remain stored on the Red Planet. But they are destined for something much bigger. NASA and the European Space Agency are collaborating on a future mission that will retrieve these samples and bring them back to Earth. This mission will represent the most ambitious space collaboration ever attempted, requiring multiple spacecraft, years of planning, and intricate coordination. When these Martian samples finally arrive on Earth, they will be subjected to rigorous analysis using the most advanced laboratory equipment available. The goal? To unlock secrets that no rover could ever reveal on its own. The potential discoveries from these returned samples could be groundbreaking, with the power to redefine the field of astrobiology and reshape our understanding of life in the universe. The implications stretch far beyond science. They delve into the realm of philosophy, raising profound questions about life beyond Earth, our place in the cosmos, and the future of interplanetary exploration. If signs of ancient life are found in those samples, it could be one of the most important discoveries in human history, one that forces us to reconsider everything we thought we knew about biology, evolution, and the uniqueness of life on Earth. In the vast silence of space, These rovers, especially Perseverance and Ingenuity, speak for us. They carry not just instruments and tools but the essence of humanity, our hopes, our questions, our courage. They remind us that exploration is in our nature, and that beyond every horizon, there is something new to discover. As we inch closer to setting foot on Mars, we do so not just with rockets and robots, but with the boundless ambition that has always defined our species. And so, the journey continues. As Perseverance methodically charts its path across the Jezero crater, every inch of progress it makes is an investment in the long-term vision of human presence on Mars. It is a slow, deliberate journey that echoes the precision of a watchmaker, each turn of its wheels a carefully calculated movement in pursuit of scientific truth. While the immediate goal is to gather data and return samples, the broader implications touch on the future of space colonization, resource utilization, and the development of interplanetary infrastructure. Every experiment and every test performed on Mars lays the foundation for what could be the most transformative era in human history, the expansion of civilization beyond Earth. NASA engineers and scientists understand this better than anyone. That is why the Mars 2020 mission was designed with scalability in mind. Perseverance isn't just an autonomous scientific lab, it's a prototype for the type of technology future astronauts will rely on. Its ability to make autonomous decisions, conduct chemical analysis, and detect hazards in real time demonstrates how robotics will serve as critical partners in the era of manned missions. These intelligent machines will scout landing zones, locate water sources, and perhaps even construct habitats long before the first human ever steps out onto the Martian regolith. The integration of machine learning and artificial intelligence in future rovers and drones will be pivotal. As missions become longer and communication delays increase, reliance on AI will be essential. Imagine rovers capable of adapting to sudden dust storms, rerouting themselves to safety, or identifying potential dangers long before they appear on human radar. Ingenuity has already shown hints of this promise with its ability to fly semi-autonomously and interpret visual data to maintain stable flight in unpredictable wind conditions. These breakthroughs are not isolated, they are stepping stones toward a fully automated Mars infrastructure that will support everything from research to agriculture to emergency services. One of the most exciting prospects in Mars exploration is the search for subsurface life. While Perseverance focuses on surface geology and ancient lakebeds, future missions may drill deeper into the Martian crust. Here, shielded from deadly radiation and temperature swings, microbial life might still exist. Technologies like ground-penetrating radar and thermal spectrometry could eventually locate underground aquifers, hidden reserves of briny water that might harbor extremophiles, organisms adapted to the harshest environments. Instruments like the radar imager for Mars Subsurface Experiment, RIMFAX, already aboard Perseverance, are beginning to peel back the layers of Mars's geological history. But they are merely the beginning. More advanced tools will soon follow, ushering in a new era of subsurface exploration. At the same time, the psychological and social challenges of long-term human presence on Mars are being studied in parallel. Even as we refine the mechanics of travel and survival, the human mind and body present complex hurdles. Astronauts will face prolonged isolation, limited communication with Earth, and constant exposure to a hostile environment. The development of artificial gravity systems, radiation shielding, and virtual reality environments for mental wellness are all areas of active research. Mars exploration isn't just a question of can we, but also should we, and how will we. It's a holistic challenge, one that touches biology, engineering, ethics, and sociology in equal measure. The human spirit, however, has never been one to turn away from challenge. The very same drive that built the pyramids, crossed oceans, and put men on the moon is now aimed squarely at the red planet. Unlike previous explorations, though, the journey to Mars is more than symbolic. It represents a new chapter of existential significance. It's about securing the long-term survival of our species, learning how to adapt to alien worlds, and testing the limits of human resilience. Colonizing Mars isn't merely a science project, it's a rehearsal for ensuring that life, in some form, continues even if Earth someday no longer can sustain us. Private companies have also entered the equation, adding new energy and ambition to Mars-related goals. SpaceX, with its Starship program, aims to transport humans to Mars within the next 2 decades. Their reusable rocket system, capable of carrying large payloads and potentially over 100 people, could revolutionize interplanetary transport. Elon Musk has famously stated that he envisions a self-sustaining Martian city within the next 100 years, a bold, controversial dream that has inspired engineers and alarmed ethicists in equal measure. Yet this commercial vision of Mars is pushing the envelope in terms of funding, public interest, and rapid prototyping of new technologies. NASA and SpaceX are not rivals. They are complementary forces in humanity's bid to become multiplanetary. Cooperation will be essential. The logistical, financial, and scientific scope of a Mars colony exceeds the capabilities of any single entity. International collaboration between governmental agencies like NASA, ESA, Roscosmos, JAXA, and private industry will likely define the next phase of Mars exploration. Shared data, pooled resources, and global expertise could lead to joint missions that reduce redundancy, distribute risk, and accelerate discovery. Just as the International Space Station served as a model for peaceful, multinational cooperation in orbit, Mars could become the next great frontier of diplomatic unity. A base on Mars may not bear the flag of any one nation but of all humanity. As we look deeper into the future, speculative technologies begin to come into view, ideas that may seem like science fiction today but could become reality with time. Terraforming, for instance, is often mentioned as a long-term goal. The process of altering Mars's climate to make it more Earth-like would require colossal effort, melting polar ice caps to release CO, thickening the atmosphere, and raising surface temperatures. While the ethical implications are immense, so too are the possibilities. A terraformed Mars could support open-air agriculture, human settlements without pressure suits, and a thriving biosphere of adapted Earth life. Though likely centuries away, the dream of transforming Mars into a second Earth is rooted in the same pioneering ethos that launched the first rovers. Even before such transformation, Mars may serve as a hub for interplanetary travel and commerce. Mining operations might extract rare minerals and ice. Research stations could develop medicines or materials impossible to create in Earth's gravity. Solar